Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about the topic of simple pendulum, in which I will discuss about that the motion of simple pendulum, in which a ball is suspended with a thread which is massless thread, and mass of the ball is m, and which is fixed with a support having length of the thread is L. So when force is applied on the ball and it moves its some position and go or move towards the peak position, and when it release it move to and fro motion across or around its mean position. So if we fix the ball at some point, and we will understand its motion and movement according to weight of the mass, weight of the ball in with regard with the mass. So if ball is stopped at its extreme position for some time, we will see that ball has weight of mg, and if we divide or resolve it into rectangular components, its rectangular components will be mg cos theta and mg sin theta, because in this case we will consider that mg sin theta as is an effective component, because the motion of this effective component is directed towards the mean position or center of the ball. In addition, mg cos theta is opposite to the tan or tangent force or tension force. That is why it is cancel out. Only effective component is the mg sin theta, and negative sign shows that it is restoring force that directed towards the center of the ball, or directed towards the mean position. So if the theta is very small, so then sin theta will become theta. It is not 0, it will be theta. So we will replace it in the form of theta. F is equal to minus g minus mg and theta with respect to sin theta, and it is replaceable. So in this case theta is very small, because ball is the movement of ball is very small. So according to Newton's second law of motion, we know that F is equal to ma, and if we equate these two equations, minus mg into theta and fa, in this case m can be cancelled out from m, and only remaining part is a is equal to acceleration is equal to minus g into theta, and this is equation 1. Furthermore, we have value of acceleration, value of g, which is constant, and we do not know about the value of theta. So in order to calculate the value of theta, we need to apply some formula. So according to definition of radian, theta is equal to arc length AB, or distance of arc length divided by length of the thread. So which will be this arc length will be x, or distance covered by the body from mean position to extreme position. So this will be theta is equal to x over L. And furthermore, if we will put the value of theta in this expression, a is equal to minus g into, this is x over L with the replacement of theta, and a is equal to minus g x over L. So this is the value of acceleration. If we are asked that what is the value of acceleration with respect to length and the arc length, we can find out by applying the expression a is equal to minus g x over L. So furthermore, we know that according to angular motion, body has some part of angular motion, a is equal to minus omega square into x. So we need to calculate the value of omega, or angular velocity, with respect to acceleration and displacement. So acceleration, angular velocity will be square root of acceleration over displacement. So acceleration, body is moving with gravitational force. We have put the value of mg, or weight, it will be replaced by g, and L is replaced by x, because body is dealing with radian part, and this L is replaced by small portion of x. So we know the value of angular velocity. In the previous video we have discussed that omega is equal to 2 pi over t, and t is equal to 2 pi over omega. So we will put the value of omega in this expression, 2 pi over g over L square root. So if we simplify it, it will be 2 pi multiplied by L over g square root, which is the time period of simple pendulum. From this expression you can see that the value of time period is directly related to the square root of length of the thread. but it does not depend upon the mass of the ball or mass of the bob. So this in from this expression in the exam or in the intertest, we can say that what is the dependency of time period with respect to length or with respect to mass. So time period of simple pendulum, please remember that time period of simple pendulum does not depend upon mass of the ball, it only depends upon length of the thread. If the length of thread is very high, the time period is high and ball will go or reach to the mean point will be later. If length is very high, it means that time period is very high. If time period is high, its frequency will be low. So please remember these things according with respect to or regarding time period or frequency of simple pendulum. If mass is increased, if mass of the ball is increased in case of simple pendulum, then what will be the effect on time period? So time period will remain constant, it will not change. Up till now, I have given some concepts related to time period of simple pendulum. I am forcing on the thing that it is a topic of simple pendulum, not mass spring system. This is simple pendulum and mass is not dependent on time period and frequency. We will finish here and we will see you in the next video. Please subscribe my channel for more videos. It will be helpful.